Welcome to another data systems seminar at University of Waterloo. Our speaker today is Kaladar Voroganti. Kaladar is a senior fellow in the office of CTO at Equinix, who are looking after technology and architecture. And prior to Equinix, he was with NetApp in the CTO's office. And prior to that, he was at IBM Almaden in the storage systems group. His degrees are from University of Alberta in electrical and computer engineering for the undergrad and computing science for the PhD. I think Kaladar gave a talk, a DSG talk, some years ago in person, and this time he'll be speaking to us over Zoom. And the topic he'll be talking about is AI marketplaces. Kaladar?
Yeah, so thank you, Dr. Utsu. And I just want to let everybody know, I was Dr. Utsu's, one of Dr. Utsu's student. And I'm very happy, Dr. Utsu, to be seeing you again and sharing some of these ideas here. Thank you for the opportunity. So folks, just before I get started, so when I started my job at Equinix, or I was interviewing at Equinix. Equinix is officially known as a real estate trust. We are a REIT, and REIT has many benefits. And so people ask me, hey, why are you working at Equinix? You're a computer scientist. Now you're working in a data center company. What's happening? I said, wait, I'll tell you how strategic Equinix is and how all the major clouds and all the major network service providers, finance companies, content delivery networks, most of the global enterprises all leverage Equinix. And so in this talk, I will talk about AI data marketplaces, and I'll also talk about how Equinix is playing a strategic role so that you get an idea on how these data centers are a very strategic part of this next generation distributed architectures for 5G, for you name it, for distributed AI and so on. So with that, let me get started. So I usually like to classify AI in like three different eras. The first era is like 1950s and Turing, and then McCarthy from Stanford, etc. In those days, and subsequently for the next couple of decades, people would manually experts would enter rules into a system, and that would basically, the AI system would basically behave based on the rules that were entered. And you all probably might have programmed, or some of you anyway, might have programmed in Lisp and Prolog, and I surely did when I was in my undergrad. And the systems were quite brittle in those days because a lot of the corner cases, etc., it was difficult to handle. And everybody ahead of time couldn't think of all the rules which might be not hidden with respect to how the system should behave. And then we kind of entered, I would say, the next generation of AI, where basically I think once in the University of Toronto, they figured out that you can use GPUs to do basically for graphic GPUs for doing deep learning, and when you combine that with a lot of data, then suddenly these neural networks, which I programmed in 80s, and at that time they were considered slow and not really accurate. With enough data, enough computation power, now suddenly they are, in many use cases like vision and natural language processing, etc., they're coming close to, human level accuracy. And also clouds have democratized AI. So basically I have I teach Sunday school, and there's a kid who's part of a group for their hackathon. These kids basically went and, mined Twitter logs on Watson. And they were able to basically predict when there will be disturbance or riots at UC Berkeley area. And they also went to Microsoft Bing library, got images of nails, and they were able to then predict what kind of potential disease a person has based on that nail, human fingernails. So as you can see, these are young high school kids who have now access to large amounts of computation power in the clouds. And clouds have nicely packaged all these algorithms in libraries that you can use. And even transfer learning, right? Nowadays, most people don't build models from scratch. They use existing models. So clouds have pretty well democratized AI and made it easy. However, I think now we're entering, I would say, a third generation of AI. Here now, governance is very important. most organizations are realizing that they need more data. They need data from external sources. And so how do you ensure that you still have the providers of data still want to make sure they have control over their data? They don't want to give their data to some other person or company. And that company can take, once they have access to raw data, they can do whatever they want. Even though legally they can say, oh, you're not supposed to use this data for unauthorized reasons, they can take that data and pretty well do whatever they want. And also, increasingly the impedance mismatch between the data scientist and subject matter expert is slowing down the amount of time it takes for a subject matter expert to get insights from their data. And also one of the other things we're finding, and this is where our company is playing a very strategic role, is a lot of data is getting generated at the edge. So for example, airplanes were generating about 4.5 terabytes of data per plane per day. Now that is going to go up to even probably 8 or 9 terabytes of data per plane per day. Autonomous cars, similarly around 10 terabytes of data per day per autonomous car when it is actually collecting data in the training mode. Smart factories, hospitals, they're all generating a lot of data. And it doesn't make sense to take all of this data to a central location or central cloud to basically build your AI models and subsequently also for inferencing. So that whole paradigm of centralized AI is changing. And we are actually, I'm involved in many projects where we're actually helping companies to distribute that. So in this talk, I'm going to talk about the notion of an AI marketplace, which is different slightly than a data marketplace. I'll talk about that and how it is going to help organizations with the distribution aspects, as well as more importantly, governance aspects of their AI architectures. So these are some trends I'm sharing here so that you see where how people are thinking about this AI and data marketplace. So most organizations are saying that data is a very strategic asset, and many of them actually want to monetize it also. But they're very afraid to monetize it because they don't want to lose control over their data. So they don't want to just give it to someone, as I mentioned before. And the predictions are that up to like around more than 5,000 companies are already like looking at where they are looking at how to monetize, buy, and sell their data. And from a data consumer standpoint, they want to make sure that data is coming from a reputed source. The provenance information for the data is there, so that, or the model, if you're leveraging an existing model, AI model, the provenance information has to be there. And they want somebody to certify that this data is what it claims to be. And usually, typically, a lot of large organizations have data quality assurance groups whose job is to look at the external data that they're getting and do a rigorous QA on that to make sure it is satisfying their needs. And data purchase trends are that historically, organizations would go to their IT group and they would go and be involved in the transactions to get the external data. Increasingly now, the data is being purchased by the line of business people only. And also, one interesting thing we are noticing is that in addition to data scientist and data engineer, those two personas most people are aware of, there is a need for a third persona we are finding that is known as a data curator. And the job of a data curator is to talk to the development teams, talk to legal, talk to finance, talk to IT, and basically figure out what data can be sold and what data can be purchased, all the legal implications, the cost implications, etc. They are able to handle all of that. And so there's definitely need for training, and this is where I think business, legal, and IT, computer science, they kind of merge. So there is a need for that new persona, and I'm anticipating new courses and more things will start for the persona for data curator. And today, still about 40% of the data is still being shared via emails and spreadsheets. People are still sending emails. So there is definitely a need for governance to basically take care of how to buy and sell this data in a more systematic way. And data providers, they basically want to make sure that they want to not get locked into a single cloud for selling or buying their data. They want to have the flexibility to keep that data in their own control so that there are no egress costs whenever they're selling it to somebody. Because unless if you store it in a cloud and sell, there are egress costs. And they also want to make sure that they have to have a copy of the data in different locations for if they have any PII sensitive data. And finally, most importantly, they want to have control over their data so that if somebody is using that data, they don't want them to just basically use it for unauthorized purposes. So this is kind of setting the stage for why there is a need for a AI or data marketplace. So basically, this picture is trying to capture basically what is an AI marketplace at a very 1,000-foot level. Essentially, and we have actually implemented this for a consortium of airlines. So essentially, what happens? There are 3 airlines, and actually there will be a real use case. I'll take you through that want to share their flight data. And the reason why is that they don't have, they're paying a premium for analytics today to the manufacturers of engine and airplanes. And so what they want to do is basically share data about a particular plane type, because they don't have enough planes of that type with a single company. So these 3 airlines said, okay, we want to share data. And then basically we want to create AI models for their bleed valve system so that they can predict if I run this plane for another 10 hours, what will happen, right? What are the potential failures that can happen? Because they want to do predictive maintenance. So what they were doing is that they want to bring their data into a neutral location. So this is the blue thing is like a neutral, secure, you can think of it like a demilitarized location where they're bringing their data. And now the interesting point to note is that they're also allowing third-party algorithm providers to bring their algorithms into this neutral location. Okay, so end of the day, this is a secure, like a Kubernetes cluster. You can think of it like a, in a secure location, where basically at both container level and at the data level and like network level, it's all like firewall, so that you cannot remove raw data out of that. And so now you're allowing these these third-party companies to bring their algorithms into this secure neutral sandbox. And basically, the reason why the airlines also wanted to do this is because they wanted to allow for faster innovation, because their own data science and IT groups were not innovating fast enough. So they wanted to allow third-party folks to come in and basically give them new insights and help to address new use cases. So these basically algorithm providers can also bring their algorithms into this neutral sandbox. And that is where basically you are able to run those algorithms on these data sets that you're getting, and you create models. And then subsequently, with permission, you can take the model out and use it for inference in your production systems, wherever you're running them. So the difference between an AI marketplace and a data marketplace is that it is allowing you to not only trade data, but it is allowing you to actually bring your algorithms and actually run them and create your models and train and build your models within this secure sandbox. And this is important for multiple reasons. One reason it is important is because it helps to actually create an audit log. So we are working with companies who use blockchain, like a distributed ledger. So they actually are able to track. In some cases, they're using Hyperledger to track exactly what data was used, what algorithm was used to train, where did that data come from. So the lineage information for a particular model that you are using, they are actually keeping track of that. And so that lineage information can subsequently, when they in turn sell their model in the AI marketplace, they can actually also provide that lineage information. And another key point about this AI marketplace is that I'll talk about is that it makes federated AI real also. Federated AI basically means that instead of moving data to a central location to do basically create your models, you take the model to where the data resides. So you're fundamentally changing the paradigm of moving data to compute. Now you're moving compute to where the data is residing. And typically federated AI orchestrators, many of them are out in the market or industry now. They are making that possible. But the problem with the federated AI is that just federated AI orchestrators are good for within a company. So if you have one company and you have data in multiple locations and you want to share and you want to get insights, they're good. But if you want to share data amongst different companies, then you need an overlay of a marketplace overlay on top of a federated AI. So that is another key point. So marketplace actually helps your federated AI to go across organizations. And finally, as I mentioned, you can never take the raw data out of this blue sandbox. You can a secure sandbox. You can never take the raw data out. So essentially, you create your model and you can take the model out with permission. Some cases we see people also use inferencing also being done in that, but Most of the cases, they take the model once it's created and take it out and inference it somewhere else. And these are some actual use cases before I get to some of the technical details. So predictive maintenance with the major airlines, we have seen that happening. The supply chain management in the Port Authority in Amsterdam, they're actually collecting data and analyzing data from many different sources. And so they also are actually using AI marketplace. Coalition cybersecurity threat. So coalition partners in real time want to analyze the data, but they still want to keep control over their data. So they are creating this consortiums for data exchange so that they can basically do analytics on real-time threats, networking and other threats. Health, we are seeing that hospitals and research organizations want to share patient data, but they don't want to, again, give raw data out. So they also want to create a secure sandboxes where they can actually exchange and share insights rather than the raw data. And then autonomous vehicles also for maps and so on. Many car companies, it makes sense. So the National Highway Traffic Safety is also trying to facilitate data sharing amongst different organizations. And finally, finance and money laundering. Again, here also different banks and financial institutions want to share data, but they don't want to give raw data away. So in many cases, they can use a combination of federated AI and also a marketplace to actually do this sharing. And the same type of we are seeing in also oil and gas area. We are seeing and large stores like large consumer stores chains. They're also basically creating these amongst their supply chain partners. So this notion of a data/AI marketplace is just starting, and we are now seeing that. Even another use case where a network equipment manufacturer, I cannot name them, they are basically for their 5G locations, they are basically taking a video of those locations to do predictive maintenance, like, hey, this cable is loose here, or this is not correctly set up, etc. But the owners of those 5G cell sites, they don't want to share the raw data of their video and give it away. So they're again now keep creating a secure location, as a neutral location where the data is being shared with this provider, who network provider, equipment provider, who is basically providing the algorithms to basically do predictive maintenance and give guidance to them. And we're also seeing government agencies, they want to share data. Today, there's no real way for them to share data. So they have pockets of data. So that's why during Katrina, Hurricane Katrina, the relief supplies were being dropped in the wrong location because there was not real sharing of data between the government agencies. So that's why they also are extremely interested in sharing data between different organizations. And what we're finding is that this sharing of data is definitely required between different organizations. But even within an organization, what we're finding is that different groups don't share data, and they're very protective about their data. And so a systematic way of allowing different groups to share data is also it's required. And so this is not just for inter-agency, but within an agency also. I think this notion of data marketplaces and AI marketplaces will be prevalent. So what is an AI marketplace? So this is kind of giving a very high-level view of the stack. So you have basically 4 layers. The highest layer is what we call as the governance layer. So whenever you have, and I will talk more about the type of different governance models, but what we are finding is that this governance layer, in our experience, is the toughest problem. The actual technical stack is the easier part. And these governance, the actual governance models for these different companies, especially for consortiums, where the organizations are of equal size, typically takes about 6 months to curate and about 2 years for it to mature. So governance model is not something that you will get it right the first time, because you have to do many things like who is a good actor, who is a bad actor, how do you kick somebody out, how do we ensure that there's no antitrust issues? Because if let's assume all the major airlines share passenger data, you can have antitrust issues because they can just quickly control pricing and other things. So so how does this governance, what is this governance model, and how to curate that is one key part of this entire data or AI marketplace solution. The second thing is the marketplace layer itself. Typically now, increasingly, I'm finding more and more companies are making this blockchain enabled. to do smart contracts for transactions in the marketplace, and also to actually keep a log of what actually is happening in the marketplace. And there are many vendors now, and these vendors are, what I'm finding, are specializing in different industry verticals. Some are good for smart cities, some are good in health, some are good in finance, and so on. So these marketplace vendors are vertically aligning themselves and providing value-added services in a particular vertical. Then you have the data or analytics layer. So here, basically, federated AI is becoming more and more dominant, and it's not easy to set up. Still, I think the usability aspects of federated AI to get it all set up is not easy, I'm finding. But that is basically what this area is mostly. And then finally, the infrastructure layer. And this is also very strategic. And I'll talk about how to place or select this infrastructure layer so that you're able to host these neutral marketplaces. And so you really cannot keep them in a single cloud, because the data that you are going to be using, most of the data is spread across the clouds, spread across data brokers, spread across private organizations, and also getting streamed in from the edge. So it's very strategic where you want to host this infrastructure or the actual AI stack. So where you are putting your heavyweight training machines like DGX or other AI training hardware from various companies. So governance. So this is just a single slide to kind of give you some overview on governance. So basically, the data, type of data, the licenses for that data, the usage conditions, what are the rules for conflict resolution, and usually you might have a third party that is part of the consortium who will arbitrate rules about data quality. And so those are all part of the consortium agreement. And then the second key part is a trust archetype, and I'll talk about that. So essentially, how do you ensure, whether you're moving the data or whether you're moving the algorithm, or data or algorithm need to be moved to a neutral site? You have to decide on the basic fundamental trust archetype for your consortium. And then the infrastructure. So many times the marketplace operator will go to a certain provider who can actually give them the infrastructure as a service. So a lot of times you see currently marketplaces being run in the public clouds, but as I mentioned, there are issues with that. And then, so who can actually provide you this marketplace infrastructure as a service? And then basically the whole, warranties and the contract frameworks, the more legal part of this also is part of this. So it takes, as I said, about 6 months to kind of get members to agree to something like this, and about 2 years for it to kind of tweak and make sure you think, yeah, I got the model. And essentially there are 3 types of governance models. So there is a consortium driven, there is a founder driven, or a single party. So if you are the largest food chain store in Canada, you might have a governance model that you articulate, and everybody has to adhere. All your suppliers have to adhere to that governance model. And then there are open marketplaces. So these open marketplaces, the operator of the marketplace sets the governance model, specifies it. And then all the participants have to adhere to that. So that there are 3 different types of marketplaces governance models. And what we are finding is that the consortium one is the longest one to curate properly. But the founder-driven one are quite fast, because it's basically, the dominant player is basically curating the marketplace governance model. And open marketplaces, a lot of the companies now you see are toying with that. Even clouds have now started creating marketplaces, and they basically determine what the governance model is. So definitely there are multiple types of governance models that are in play today. And marketplace layer, I'm just giving you an overview of typical workflow in the marketplace layer. So essentially you have setup phase where you are setting up the governance model, and you're setting up, who's the infrastructure provider that you're going to use. And then you have the member admission. So then basically you bring in members who agree to the governance model, and then you basically, they kind of basically come and register themselves. And then you have asset registration. So assets can be data, AI models, and also any type of third-party services. They can also be brought in, like security services, data anonymization services, you name it. So they will register themselves and their assets in the catalog, in the marketplace catalog. And then you basically have trade agreements. So this is where a party A says, okay, I'm going to sell this data to this other party. And typically you have smart contracts being established. And then basically this is where there are agreements or how long you're going to have this data for. Like you might say, I will only sell it to you for 1 month. After that, the URL or the link to that data is basically invalid or is gone. So essentially you have trade agreements, and then you have actual AI transactions. This is where you're actually saying, okay, I'm going to take this AI algorithm and create a model on three data sets, and then basically you have your own secure enclave as a consumer, and then that's basically where you are actually doing the model training. And finally, the clearance and settlement. So basically, how much the providers are charging for the data, how much you have to pay for the actual infrastructure for using that infrastructure. All of that is basically aggregated, and you get a bill for a particular transaction or set of transactions. So as I said, most of it, marketplace vendors now are making this blockchain enabled. And these are distributed. So the control plane is basically distributed in the sense that the data sharing plane or the data exchange plane can be distributed globally. And you have a single namespace in the actual data marketplace so that your catalog has a single namespace. And essentially, you can have nodes where you're doing data sharing or data exchange globally. And so we are already seeing actual deployments of this type of marketplace, which are distributed across multiple regions. And the trust archetypes, as I mentioned, there fundamentally we found there are 3 trust archetypes that we are seeing people use. So the first one is compute to data, we're seeing. So this is something where what we are finding is the federated AI orchestrators are being leveraged. So essentially what happens there is that you send your algorithm to the different locations, distributed data locations. So let's say you have 3 airlines and they all have the data in 3 different locations, and you want to build a global model for a particular type of aircraft. So you will send your AI algorithm to 3 different locations, get local models built from these 3 locations, and then you aggregate those local models in a central location, and then you create a better global model. And then you push that global model to these remote locations where they can use it in their actual production systems. So that is definitely something new that is happening now. Compute to data, where we are seeing the emergence of many type of federated orchestrators now. Then let me go to this other one, data to compute. This is the normal way of basically doing data exchange nowadays, where a lot of companies basically take their data to a cloud, and then they basically share the data in the cloud with other parties. So here, basically, you're moving your data to a location, which is some cloud or some other third-party location, and then you're actually running the algorithm in the cloud, etc., to create your models. And so data to compute is a very common approach nowadays. And then the third approach we are now finding many organizations ask for is the moving compute and data to a neutral location, because in many cases, the algorithm providers are hesitant to move their algorithms to a remote location because they don't want others to know what kind of data they're using, etc., as part of their model building. And so they want to, because in many cases, they bring their own data sets, to improve the model accuracy. And so they want that privacy. And so basically, algorithm providers want to go to a neutral location, data providers want to come to a neutral location, and then they basically do their model building there. So this is basically, we are seeing this, especially in large organizations, like I mentioned, the telco vendor. We're also seeing this in, between the different government agencies, where they also are very particular about, moving their algorithms to a neutral third-party location. So they want to bring it to a neutral location. So the consortium members agree to have a common compute location, and they basically want to do their data and algorithm exchange in that location. And they have rules about physical security, network security, data security, application infrastructure level security, and all different levels of security. They have rules in the governance model. Analytics layer. So here, basically, the key point I wanted to make was, historically, most people are aware of the centralized AI model, where you take data from all your different data locations where it is getting generated, go to a central location, and you actually do your model training there. And then basically inference also, you do it in the same central location where the model is getting built. In the federated AI model, essentially what we are seeing is, essentially you have local data sources here, and then you move the model to the local data sources, you create local models, and then you move the local models to a central or a coordinated location. It doesn't have to be a separate location. It could be in one of those locations also, logically a central location. And you do a model aggregation there, and then you subsequently move the model, the model to the locations for inference. So federated AI is definitely something we are seeing, especially when the data set sizes are large. And also when we see that when people want privacy, like in the hospital use case, where the customer data, they don't want to move or ever let it leave their security perimeter. And these are some federated AI frameworks right now that I have looked at and I've used. So the KubeFate it's an open source. VMware is now making it containerized and they're calling it KubeFate. That you have NVIDIA Clara, Federated TensorFlow, PySift, which is open source, Flower, and so there's Zane. So there are many different federated AI frameworks out in the industry. I'm finding that they're still not that usable, so you have to have some spend some amount of time to make them work. But that is going to change over time as people make it more and more easier to use. And essentially, the three types of AI training models that I'm comparing here are: this is a federated, where I'm showing where the local models are sent to a central location and aggregated. Then there is a distributed, which is basically you just build a model with the local data and use it there. So this is not really accuracy-wise, you might not have the best, most accurate model in a distributed approach. And then central approach, where you are sending the raw data to the central location and building the model. So accuracy-wise, central is the best because you're getting all the raw data to a central location. Federated, we are finding is that many cases shipping the local models to a central location are within around 5% of the accuracy in many cases, and that might be, pretty good for your use case. And some cases it might not be acceptable. So depending on the use case, and also not all AI algorithms are amenable to federated way. So depending on the algorithm, depending upon the accuracy that you want, federated might be just as good as the central model. Bandwidth, obviously these are much more efficient because you're not sending 4 terabytes of data per plane to a central location. Instead, you'll be shipping a local model, which is in the order of a few hundred kilobytes. Privacy, also the federated and distributed way is better because raw data is never leaving the security perimeter of an organization. And inference time also, obviously, you're doing it much closer to the edge, and rather than shipping like large amounts of data to a central location to do model inference. So this is also much better with respect to these two, federated and distributed. But the accuracy in the federated can approach the accuracy you get in a centralized, whereas distributed, depending on the data set, your accuracy might be really not that good. So essentially, we are seeing the emergence of the federated AI model. And as I mentioned, the marketplace overlay on top of this federated AI is very important because it now helps you to share data between different organizations. So that is a key symbiotic relationship between data marketplaces and distributed AI frameworks. So that is something, that's why in the stack that I showed, that is just how we have architected it. And this is the predictive airline use case. So basically the bleed valve system that they had, they wanted to create an AI model of that to do predictive maintenance and say how many hours can I, basically run this plane. And essentially what we did is we created we used random forest training, and then basically, the key points to note is that we basically had 3 different distributed locations for the 3 airlines, and we had a consortium cage which was at Equinix, and essentially we basically leveraged the data and 3 different locations and created local models, and then we shipped those local models to a central location to do the create an aggregate global model. And then we ship the global model back to these locations. And we use one of those frameworks that I mentioned there to do that. And the key takeaway was that the accuracy of the federated way was around within 5% of the central approach. But the cost of data transfer was really 99.9% lower data transfer cost because we're shipping only the models versus the raw data. So in this particular use case, the airline consortium said, the 5% accuracy lag is okay for them. I think they thought that the cost savings they were getting with respect to not shipping a lot of data was worth having this 5% accuracy difference in comparison to a centralized approach. So this is one use case. We also did it with a health organizations, and there also the centralized approach gave us the best, most accurate results. But the federated approach, once again, was almost within 5% of the accuracy. And they also were sharing patient data because of using that federated approach. Infrastructure. So this is where I'll talk about our Equinix and why we are involved in this AI project, right? We are a data center company, end of the day. How are we strategically involved, and why we are partnering with other companies to make this AI marketplace a reality? So essentially, the key point that we wanted to articulate is that host your AI training, your big, huge, your DGX or your Cerebrus machines or any machines that you have, NVIDIA DGX, the training machines, you want to host them in an interconnection hub, like an Equinix location. And basically you're getting data from data brokers, you're getting data from public clouds, private data centers, and essentially very strategically you can host your the infrastructure stack, AI infrastructure stack at a location like Equinix. And essentially what we have done is that I'll show you why is locating it at Equinix very strategic. It's a data center, and I'm going to give you 2 or 3 slides reasons why Equinix is a very strategic location, and a lot of people are hosting their AI/data marketplaces at Equinix. So when you look at Equinix Data Center, there are different types of data centers. First of all, so there are what we call as a wholesale data center, which are more compute and storage intensive type of data centers. And they're typically hosted where power and water costs are low, like in the middle of Oregon or middle of some prairie in US or in Canada. Whereas we are what is known as a retail interconnection dense type of data center. And so this is something which is important to note. So Equinix data centers are very strategically located within 10 milliseconds of the end customer devices, like Teslas or your smartphones, within 10 milliseconds round trip network latency on one side. And we are also located within 1 to 2 milliseconds from the cloud or hyperscaler data centers. So Equinix data centers are very strategically located. And so we are in the edge. And so that's where these airlines and other companies want to bring their data, because we are located in every metro, well, pretty well every global metro, and that's where they want to do the data exchange. So for example, just like an airport, I like to use this analogy, just like an airport is a hub where you have all these different airlines coming and basically passengers going from one airline to another. Equinix is like that so basically all the clouds, networks, we have about 4,000 clouds, about 17 to 1,800 networking companies, content and all the content in digital media. I'm just showing a few logos here just to illustrate. So we have about 10,000 of these companies that are interconnecting. So this is like in one data center, each of these red lines that you're seeing is one interconnection between 2 organizations. So this is like almost like an airport. You can think of it where you have airplanes. Here you have different cages in Equinix data center, and basically the organizations are interconnecting. So like all the clouds, they come because they want to push their content to all the network service providers. Network providers come because they want to take the content to all the different clouds. So that N-to-M relationship is very powerful, and Equinix actually makes that happen. And essentially, what we are finding is that increasingly with COVID, more and more of the data traffic patterns globally are getting decentralized. So customers now are saying, hey, I don't want to take my traffic that is originating in a particular metro, take it to a centralized location, apply network policies, and then route it to a public cloud. Instead, what they're saying is that we want to apply the security and network and security policies in that region itself where the traffic is emanating, and then route it to the appropriate cloud. So more and more, we are present in more than 60 metros globally. So more and more, we are finding that organizations are basically leveraging their hosting their networking stacks, both physical and virtual. We provide virtual networking stacks also for virtual firewalls, virtual load balancer, virtual DDoS, machines, VMs. They're hosted at Equinix. You apply the security policies, and then you send the traffic globally. So basically, we are like a airport, and we are located in all these global locations, and this map keeps changing. Now we also have something in Chile. We, a couple of years ago, purchased something in Canada. So as you can see, many different locations in Canada we have. We now also have in India. We also have in Africa now. And basically, globally, the whole idea is that within 10 milliseconds round trip to the end customer, we can provide the latency. And now what we're finding is that even 5G providers are basically coming and hosting, because in many locations we can provide even within 5 milliseconds round trip latency. And so now they're actually providing and hosting their 5G mobile core, and also MEC, the MEC also, where you're doing processing in the 5G MEC. They're getting hosted at Equinix locations globally. So definitely, this is what we are seeing, how the 5G networks are getting architected. So in conclusion, what I would like to say is that just like, initially we saw interconnection at Equinix between different telcos. That's how we started in late 90s, early 2000 area. That's when the internet boom started. So basically all the telcos said we need a neutral location to do data exchange. So the telcos were coming. Then subsequently the finance companies said latency is very important to us. So all the financial ecosystem, they all basically came to interconnect in like New York and London, etc. stock exchanges, they came. And the content companies, the CDN companies and the content generators, they came to also interconnect at Equinix. Then in around 2014, the clouds had to now push their content to the end users. So the networks and the clouds, they started to basically interconnect at Equinix. And then, last 3-4 years, enterprises now, they're all saying we want to have secure private global networks. So we have something called as a fabric, which connects all these 240 plus locations with a fabric. So they want to have a secure private network. And now finally, we are entering the era of AI exchanges now. So we are also seeing now, not at the networking level only the interconnection, but also at the data and AI level. People are now hosting the AI exchanges also at Equinix. So in future work, there are 3 things I'm noticing that I think research areas where students can actually explore, and there are, I think, fertile topics. One is when you have multiple network marketplaces, what are the protocols to allow for communication, control plane communication between different marketplaces? You might have an automotive marketplace, you might have a weather marketplace, etc. And so an organization might want to participate in multiple marketplaces. So how do you allow for that? So that is one area I think research and work is required. Second thing where we want is the automatic algorithm validation. So as algorithm providers are bringing the algorithms into the secure marketplace that I talked about, we want automated way of checking to make sure for any maliciousness in the algorithm and so on, rather than manually certifying that this algorithm is good. I think there is some thinking required, I think, in that area also. And the third thing, as I already mentioned, there is a need for the whole area of data curation for like that be more rigorous and scientific, and like that persona being developed in colleges and universities, so that we train a next generation of data curators who will be very strategic to make this data and AI algorithm sharing possible. So with that, Dr. Otsu, I'm going to stop, and then I'm ready to take questions.
Thank you, Kaladar, for a very interesting talk. New stuff is coming on board all the time. Good for us to know. Before I open the floor, there are 2 questions on the chat. So Grant, you were the first. Do you want to unmute yourself and ask the question?
Yes, I enjoyed the talk. So if you were to go back to one of the earliest slides, I guess number 3 or 4, you had a diagram where you had the data on one side and the algorithms on the other. High level question, like if somebody deposits an algorithm that's going to access the data, presumably the algorithm has within it queries or ways to express questions of the data.
Right.
What's the nature, generally speaking, are there thousands of different languages here, or is it SQL everywhere, or what's generally
right. Today it's basically mostly between trusted parties, And typically it's AI, like deep learning algorithms that they're using. And also some ML algorithms like random forest, etc. So these are the types of AI algorithms that we are seeing today. People are using to create their AI models. But that doesn't mean that you cannot do queries and so on. I think that is also definitely, that is in the realm of possibility. But the trustworthiness of this algorithm, etc., I think it's usually the marketplace operators who are kind of reviewing it and making sure that the users are not doing any malicious things. And also there is a level of trust between the parties. And so in the AI marketplace, the consortium members, they pretty well have, they're all have legal agreements in place. And the AI marketplace operator usually helps facilitate between the buyers and the sellers to make sure that there is no malicious intent.
I guess part of the question is clarifying exactly what the data is. Do I think that the data, can I just think the data is the contents of tables, or is it something else?
Data can be video.
Go ahead.
Data can be video images, video streams. Data can be content like raw, like semi-structured social media, feeds. Data can be also structured if you want to do structured SQL queries. I think all three. This marketplace notion doesn't exclude any type of data set type.
Thanks.
Yeah.
Ed Chernovsky, Ed, you had a question. Do you want to?
Yeah,
ask?
I'm sorry. I just wanted to know, we hear now a lot of reports coming in concerning data poisoning or malicious use of injection of inaccurate data. How do you control that in a data center when you have your algorithm searching for certain results and you're looking for results, to use this data? How do you maintain trustworthiness in the data that you're receiving?
Right. So as I mentioned, there are layers of software in the stack. We are the bottommost layer. We are the infrastructure layer. And essentially what happens is that the marketplace operator, when they curate the consortium, they basically get all the parties to agree on the type of data they would like to bring in. And then there are third-party services that are also part of the marketplace, whose job is just to validate the data that is being brought in, and they charge a certain transaction fee for doing that validation. So to give you a very concrete example, I'm bringing this data in, and there should be no PII information, personal information in that data. But the personal information might creep in, and that is a violation of the rules of the marketplace. So this data, in some cases, the data marketplace operators themselves have a service that you can get, you pay extra, where they actually go through your data to make sure they identify any type of personal information that is there. And in some cases, third-party companies can come and say, I will provide this as a service, and they register their service in the marketplace so that you can use that also as part of your AI pipeline. So essentially, you have an AI pipeline, and there you can have multiple services, third-party services, like for anonymization, for detecting for PII data, and for other whether there is any certain different types of data that you might not want there. These services can be part of your pipeline, and these could be provided, or these are provided either by the marketplace operator or by third-party services. And so by the time the data gets cleansed, and by the time you scrutinize the data, and then subsequently you finally say, yeah, this data is good enough, right? I'm okay with the lineage information, because everybody, when they register their data, they also have to specify the lineage information. So, and the trusted party. So the trustworthiness of the data is certified by the consortium, legal agreements, by the marketplace operator, and also by our tools, third-party tools, as I mentioned. And then once everybody says this is a certified data set, it is registered in the catalog. And subsequently, when you're using that, you will know that, okay, yeah, this data set is certified, and then therefore I can use it. In some cases, the data set might not be certified fully to the extent that you like. And in that case, the buyer has to be beware of the type of data that they're getting.
So you have a provenance associated with the data sets.
Yes. The provenance, two parts. One is the provenance once the data is in the data set, in the marketplace, and you're operating on it, you're massaging it to make it better, and you're using that data to create different AI algorithms, definitely the provenance information is being tracked. But at first time when you're bringing in the data into the actual marketplace, there are tools to do some amount of checking to validate that the rules of the consortium are not violated. So for example, I say no PII data should be bought and sold in this marketplace. But somebody is bringing the data accidentally or intentionally, they might have PII data. So we will try to catch that and say, no, this data cannot be registered in the marketplace.
Thank you.
Okay, I will open the floor. Anybody has questions, just unmute yourself and ask, please.
Do you mind a follow on from me, Grant?
Go on.
Go ahead, please.
So one of the kinds of data that your company stores that others can negotiate access to is structured, you said. So I'm just wondering, in the structured case, do you have metadata? Do you have database schema that is also being shared?
Yes.
The
Yes.
phenomenon?
Right. Absolutely. So by the way, just one point, we are not, this data marketplace is not our data. If this data marketplace is third parties are coming and transacting, we are just enabling the data marketplace. So 3 airlines are talking to each other, or oil companies are talking to each other, etc. And absolutely, in addition to the raw data, they also, in many cases, have to provide the metadata so that the consumers understand what the structure of this data is. And that is also part of the catalog.
And one final from me.
No problem.
I'm ignorant here, but is an example of data that can be shared by your clients also what you call a model, like a trained neural network?
That's correct.
That's an example of data.
That is correct. Yeah, absolutely. And that's the key difference between just sharing only data versus sharing AI models. And not only that, but also allowing for the running of those models on that training of the model with the data sets that are in the marketplace, and then finally taking that model out, the global final model out for actually inference purposes in your production environment. So that is the difference between just pure data marketplaces and /AI marketplace.
Thanks.
Yeah.
Jimmy, go ahead, please.
So for verification purposes, can you discuss the roles of things that are provably guaranteed, from a mathematical sense, and then from the other perspective, an old-fashioned way of getting an auditor to just come in and audit the marketplace and audit the governance rules to make sure that everything is kosher? What's sort of the balance that your organization is currently taking, and how do you see the two roles evolving as we move forward into the future?
Right. Today, as we know, most of the marketplaces that are being curated, it's being manually done. It's being done manually by the governance organization that is creating or curating the governance model. They're basically saying, this is the type of data that can be brought in. And then if a customer is trying to bring in an algorithm and say, I want to use this algorithm, the auditing of that algorithm is done by either a third party or by the marketplace operator. And then basically they say, yeah, I certify this algorithm, is okay. So most of that is being done manually. And usually it is the marketplaces, especially the consortium type of marketplaces, are mostly between trusted parties. Most of the public marketplaces that we're seeing are mostly in the realm of data sharing only. Whereas data and AI algorithm sharing, we are finding is that it's typically between trusted parties, and also between if you have one super user marketplace, like a big organization, it is setting the governance rules and it is saying, I have my AI algorithms. So the partners or the supply chain providers pretty well trust that because they want to be part of that ecosystem, right? So they basically are willing to share their data because they're getting very tangible value out of it. So as it stands today, it's mostly manual, either through the marketplace operator or through third-party services. But going forward, this is the area where we believe that there is opportunity to do more automated analysis and determining that, yeah, this model, probabilistically is this much, we believe it is not contaminated and so on.
So what I'm trying to get at is, there is a policy solution and then there is a technical solution, right? And so some problems are better solved via policy and audits and governance and things like that. So do you think the researchers, do you think we're working on the right problems within this broader context? Are we working on problems that, can be solved by better governance, or, where are the real problems at?
I believe that you need both. I believe that you need to have a governance model in place, but I don't think a governance model will be sufficient going long term, because increasingly the time it takes to audit and certify algorithms is long. And you want to allow for people to quickly add their algorithms into the marketplace and use it and so on. And so just like you're putting your apps in the Apple Store, right? And you're putting your apps in the Google Store, right? And similarly, this is putting your data and algorithms into the data marketplace here. And so there is definitely need for automated technology-based solutions to audit, or at least be assisting the auditor, manual or human auditors, assisting them to say that, yeah, I think this program is okay, or this program is not okay. Today, we are not there. Today, it's mostly manual. And also more importantly, today, it's between only trusted parties. Like these are large organizations with a lot of legal muscle power. So they are all kind of agreeing to that. But in future, to make these marketplaces more common and more easier to use, there is definitely need for technical solutions to complement these more human, legal procedures.
All right, thank you.
Yeah.
Shi, you had your hand up.
Hi, Clara. Thanks for this very, very nice talk. I think I have some questions regarding privacy concerns for federated learning, and definitely excluding PII is part of the important aspect, but there also have been a lot of recent studies such as membership inference attack that shown that even for federated learning, privacy for individual records can still be learned, right? Whether have been used in their training model or not. Is this part of the problems that would be considered by the marketplace, or it's part of their the other stacks you have mentioned earlier, for example, third-party responsibility?
So today, in the federated learning, the responsibility of the privacy issues is being managed by the federated orchestrators. So for example, in the cube fate, they're using homomorphic encryption to make sure that the model weights are properly encrypted, and subsequently, as you're sharing those model weights between the coordinator side and the client sides, it has been protected. Whereas there's another orchestrator by NVIDIA, which is actually using differential privacy. So they're adding some salt into the model weights to make sure that you are not able to figure out the actual data. So I think today the responsibility in the federated learning case is being handled by the federated orchestrators themselves, and they're all using different techniques. So there is no one single technique that is being used by all the different federated orchestrators.
That's good. Thanks for clarification. Thanks.
Yeah, no problem.
Okay, any other questions? I don't see any raised hands, so let's thank Kaladar again for the talk. Thank you, Kaladar. And it's very nice seeing you again. Hopefully I'll see you later in person sometime.
Yeah, absolutely, Dr. Jose. Thank you for having me. Thanks everybody for joining.
Thanks.
Yeah.
Take care. Bye-bye.
Bye.